So welcome everyone. I'm Jan Michalewski, one of the co-founders of the Cryptosat project. I'll present a couple of slides and a short deck to tell you a bit more about what the project is about, the team, and then tell you about the bounties that are we put together for this Blockathon. So let me quickly share the screen. All right. Okay, can you see it, guys? See everything well? Cool. So welcome, koalas, and we're gonna learn to earn with the Cryptosat. So let's get started. So Cryptosat is the project at the intersection of space and crypto and blockchain. Space, like literally outer space, and satellite technology. And it's all about trust in space, and I'll explain what it means. So our mission is essentially to build satellites that power cryptographic and blockchain applications. And we do that by placing what's called the root of trust in space that can guarantee ultimate trust and transparency for very sensitive parts of blockchain and ledger protocols. And I'll dive more into the different potential use cases around that and some of the work that we've already been doing with partners. And explain how can you potentially take part in it and contribute to this project. So before that, a little bit about the team. In terms of the founding team, it's Jonathan Weintraub on the left here and myself. And Jonathan is a brilliant guy. He was one of the co-founders of an organization called Space AL, which is an Israeli NGO that operated and did the first privately owned and operated mission to the moon, and they launched the spaceship moon mission in 2020. They got to the moon, it crash landed, but they still had a good time doing it. So now they're working on the second spaceship. So this guy also has a lot of experience in launching satellites, and he's bringing all the aerospace expertise to the project. On the team, we also have people from the aerospace industry that worked on those things in the past.
I get it. Learning something new can be drive through it, which is awesome, and much like all of you. So
I think we need to mute somebody here. Daniel, hear you?
We can mute James, is it?
James.
Kick James? Where is it?
Okay, I've muted.
Okay, muted. Okay, let's continue. All right. Yeah, so we also have Daniel as our blockchain ecosystem advisor, Omer Shlomwitz, who was the co-founder and research of Zengo, which is a successful company in the blockchain custodianship world space. And myself, I got my PhD in applied security and privacy at Stanford University. And that's how I essentially got into crypto and blockchain as well, working on things like formal verification of smart contracts and more some theoretic cryptography. And in the past, I also co-founded a startup that's called Anjuna, that's more in the kind of traditional enterprise security space. And now I'm working on the Cryptosat along with Jonathan and the rest of the team. So let's talk about Cryptosat satellites and how they can help various aspects of blockchain and crypto. They serve as they're essentially intended to serve as a root of trust, a cryptographic root of trust. And what it means, it's essentially can be a trusted party for performing correctly in a trustworthy manner all kind of cryptographic operations that you gotta trust that they're performed by a party that doesn't do anything maliciously or doesn't forge any parameters. So imagine, for instance, something like trusted setup, for instance, for something like zero cash. That was a big thing at the time. If you're familiar with zero cash, the scheme relies on a trusted setup that involves some generation of parameters that are then published, and those parameters cannot be backdoored. So there was a whole huge thing around doing a ceremony around that, bringing people to observe it, inspect it, audit it, to make sure that this ceremony that kicks off the whole protocol is trusted. And there are many complications with such a thing, including kind of how you create trust in those parties, questions after the ceremony around whether everything was kosher. So basically, a lot of times in blockchain protocols, there comes this need around having a trusted party. And the idea here is basically having a physically isolated environment, because it's in space, it's a satellite in space that you cannot tamper with, and you cannot do anything to it after it's launched. So you cannot change the logic. You cannot physically access it to extract any cryptographic keys, signing keys, or encryption keys. And it can be used as a trusted party for different aspects of blockchain protocols. And we can also customize kind of based on different use cases, create different functionalities that are needed for different protocols. So as I mentioned, it's tamper-proof, they're physically inaccessible, and there's no technology nowadays that really enables to, say, capture a satellite and do something to it. You can potentially, if you're a nation state, if you're a very powerful, well-sponsored attacker, you can potentially shoot down a satellite, but you cannot kind of mess with it and changes its operation. Another point is that they can be transparent in terms of what they transmit. So there are multiple options. One can be transmitting encrypted content to a certain party that asked for it. But sometimes you want multiple parties to see the same values or to see the same state. For instance, you want, say, the hash of the most recent block on some blockchain. And you want to distribute it in such a way that you cannot have different views presented to different parties, which can happen on a terrestrial network, because you can send some packets to one client, different packets to another, and then they need to kind of gossip between them, coordinate, which can be complicated in order to make sure they got the same, and they see the same view of the state. Whereas with something like a satellite transmission, you can potentially receive it with multiple separate and independent ground stations, and you can see that you basically guarantee that as long as you're pointing them to the same satellite, that you're getting the same transmission. And it's very hard to kind of circumvent that. Recently, during the past 10 years, there's been a tremendous advance around those technologies, around the small satellite technologies, and the satellites that we'll talk about, they're becoming pretty low cost to launch and maintain, including even infrastructure that enables you to transmit and receive through to those satellites through basically public clouds. So apart from kind of more traditional ground station infrastructure, you can even subscribe to, say, a special offering by Amazon or by Microsoft Azure, and you're able through those public clouds to transmit to satellites, which is quite amazing. So that's a little bit about crypto satellites, and let's take a look at kind of the models that we're aiming for. So Cryptosat is aiming to use CubeSats. It's a small satellite. It's kind of a standard in this space. It's essentially those small satellites, and you can see this coin that they put here for you to get a sense of what the dimensions of it. It's like the size of, say, a big coffee mug, or like this small cube that can be made from off-the-shelf components. And this standard enclosure essentially enables you to put affordable hardware that's kind of standard and can be purchased off the shelf. And assemble your satellite, and we see dramatic decline in the cost, and also in the cost of launching those small satellites. So because they're small, you can also bundle a bunch of them and send them with something like SpaceX or some other company, and that's pretty affordable compared to kind of more traditional, say, communication satellites. And that's why we think they're very well suited for applications that require this kind of root of trust or a trusted party. Just zooming in on that's an example of how it can look from the inside. That's kind of a CAD design of a satellite. So basically this enclosure with a couple of boards. One of them is the onboard computer that runs the logic. Some more cards for transmitting and receiving, antennas assembled on the side of it, and this whole thing is covered by solar panels to power the satellite. All right. So what I want to talk now is a couple of bounties, and I know I kind of very briefly went over what Cryptosat is, so you're welcome to then ask more questions on the Discord and reach out to us. But in terms of the bounties, we're essentially doing a couple of things. So first of all, that's like a mini bounty. That's like a precursor to the actual thing. But one thing that we're doing as part of this whole effort is an upcoming experiment aboard the International Space Station, the actual NASA-operated and the actual space station that's kind of involves the collaboration between NASA and additional countries. So we're essentially doing an experiment pretty soon around signing data in space with the keys that we generate there. A couple more cryptographic protocols that we're testing how they operate with such a long distance and delays. And one cute thing we put together is what we call the Cryptosat bot that essentially enables you to tweet at us and send us a message, and we'll get it signed aboard, digitally signed aboard this International Space Station and tweet it back to you. Tweet you back this kind of a certificate that tells that it's certified by Cryptosat with your message. So essentially what you need to do, and I can show you an example. And it takes time for this whole thing to load. Yeah, so what you can do is essentially to tweet at us. Take a look at this example. You basically tweet, mention Cryptosat bot somewhere in the tweet, and tweet your message. And then you'll get back, not immediately, we'll basically run the bot closer to the experiment and collect all your tweets, and then tweet the responses back at you. So you'll get this nice certificate from Cryptosat that's actually signed in space. So that's one kind of mini bounty. And that would be helpful for us as well, kind of to test this out and give you this nice little gift. So that's tweets from space. And the main thing that we're going to focus on in this Blockathon is what we call the Cryptosat Simulator, or CryptoSim. We'll actually go to simulator.cryptosat.io, and I'll repost it again in Discord. You'll see this Cryptosat Simulator, which is essentially a sandbox simulator slash. Sorry, I'm not. I guess we better mute something. It's essentially an interactive tutorial that explains what Cryptosat is about and showcases a couple of potential use cases with Cryptosat. So for instance, one very basic one is getting something signed digitally by the crypto satellite in space. So, and you can try this out on your own. You can print some message. And get it signed. So that's just a simulation of how it's all going to work once we actually launch a satellite, which we're actively working on. But that gives you some ideas about the APIs that you can expect from such a cryptographic satellite. So for instance, here I created this sign-in request. I'm going to check the status first because I want to make sure that the request has been fulfilled. And sometimes it won't be ready until the satellite reaches is within reach of a certain ground station. So for instance, this green dot can potentially become red once the satellite is out of reach. And that can happen, say, when we're kind of far away from the ground stations above the Atlantic or the Pacific Ocean. But in this case, it was fulfilled pretty quickly, and then I can get the result. So I see that I got this array that contains the digital signature. And that's just one example of how to use the satellite. It also provides things like its public key, using which you can verify the authenticity of every response of the satellite, because everything the satellite transmits is going to be signed. Or you can get trusted timestamp. You can essentially get kind of source of trusted time, which can be useful for various smart contracts that otherwise need some Oracle or some other contract to kind of tell them the time, and it might not be reliable if there's some incentive to lie about this this time, the time that has passed. That's the Cryptosat Simulator, and there are a couple of bounties around that that we're going to give. So essentially, there are three different tracks, three different things you can focus on, or potentially you can work on a couple if you want to tackle more than one. So the first one is Space Inventor, and that's like super interesting for us. We basically want your ideas. We want you to think how you would potentially use crypto satellites and such a root of trust or trusted party in space, and extend the Cryptosat Simulator with new use cases. So suggest new use cases and add a kind of tutorial page for it, implement the use case, add the functions that are needed to the JavaScript API, and extend the simulator. And I'll explain how to submit those your work. The other one is Space Designer, which is around kind of UX and UI design for the Cryptosat Simulator, where you can design some cool new theme or improve the current theme and submit your work. So that's another bounty. And then the last bounty is around reporting and fixing kind of substantial bugs in the Cryptosat Simulator. So it's a fairly fresh thing we developed. There might be different problems you might encounter with it, so we welcome everybody to take a look and try to find bugs and submit your fixes for this simulator. I pointed here to a couple of resources that might be useful. So first and foremost is the Cryptosat Simulator itself. That's the kind of the online version. That's at simulator.cryptosat.io. And then we have a couple of relevant repositories. One of them, the main one, is CryptoSim, and then it has two libraries it relies on: CryptoSim visualization and CryptoSim tutorial. So in order to start working with that, take a look at this last one, CryptoSim, and the README will tell you how to get started with running this Cryptosat Simulator on your own machine, and from there you can start developing either extending the simulator with a new graphical theme or developing additional use cases. So that's pretty much it. I'll repost those links on the Discord again. There are some more general resources, such as the Cryptosat website that tells you in a very high level what Cryptosat is about. There's the Cointelegraph article that you're welcome to check out. That provides some background to this project. And there's a white paper. So if you really want to dive into the details and kind of the initial ideas around this combination of space and crypto, there's this white paper that Jonathan and I published a couple of years ago. It's less focused. It's not only focused on blockchain and crypto use cases. It also talks about more traditional cryptography and public infrastructure. but it can be an interesting read in terms of understanding, kind of diving more deeply into the justification of using such trusted parties and what they can provide. And I'll share the links to that on Discord as well. So that's all I had. Yep, I'm happy to take any questions in context. So things like that. You can even think about something like a very simple ledger. So imagine like the simplest ledger you can do is simplest trusted ledger. It can be more complicated than that, and we're working on some ideas around that. But a simple ledger can be just one trusted satellite that receives some history of transactions, and signs it and transmits it and starts transmitting it. So that basically enables you some truth for which transactions took place, or signing some hash of the history of transactions. So that can kind of be like a poor man's or a very simple blockchain using one trusted satellite that, for instance, doesn't need to require proof of work or proof of stake, which have potentially certain downsides or are not energy efficient. So you can kind of go wild with this and imagine all kind of things. So that's exactly what we wanted to do, kind of start thinking about how you can use this trusted party. And you're welcome to kind of ask more questions or bounce ideas with us over Discord, and we'll try to provide feedback on those ideas.
Okay, great. So as it currently stands then, it's not tied to any particular blockchain technology. It could be used off-chain or on-chain or with Web2.
Yeah.
Okay. And,
bottom line, yes. Like it's kind of a cryptographic API.
One other quick question. You said at the beginning that one of the advantages of this was that it would be completely tamper-proof. But I assume you still must have some way of pushing code updates to the satellite if you needed to, right?
So that's a good question that comes up a lot. Essentially, in terms of our plans, and we foresee doing a lot of work around that because that's like a critical question. We don't necessarily need to push code to that. The first satellite, the first prototype satellite we're planning is going to be upgradable because we're going to basically be testing a couple of use cases there and updating the functionality. But then what we foresee is locking down satellites for specific use cases. So for instance, if there are like say one or a couple of use cases that are addressed by a certain satellite, we'll do a code freeze and we'll essentially prevent any further upgrades, or from the get-go launch this kind of stable satellite that doesn't enable to update the functionality. And that's for certain use cases. Sorry?
So in a way, you can almost think of the satellite as becoming immutable in itself.
Yeah. And if we want to support additional use cases, we'll need to launch another satellite. Okay, and the whole point is that it's affordable enough for us to do that and launch every now and then. We'll be launching basically more than one satellite a year.
Okay, thanks.
I've got a question. How fast is the transaction speed when you're uploading the data from here?
Perfect. It's a really good question because there are obviously constraints around the satellite communication. Satellites have a whole range, and that's actually something that my partner Jonathan will be able to clarify and kind of dive deeper into, and that's a good question to also potentially bounce on Discord. So communication, for instance, the more high-grade communication satellites, they can support huge rates. It's feasible to support gigabits per second, but that's a bit hard. That's not necessarily the first satellites we're going to launch. What's interesting for us to focus is low bandwidth use cases, and there are many of those, and that's around kilobits per second, potentially going to a megabit per second. So, like exploring these use cases that are a good fit for that, it's really interesting for the first stages before we kind of go into more complex hardware and launch kind of more expensive satellites. And you can imagine that, for instance, for something like high stakes protocol launch where you need some randomness and which is not too much data, that's very doable to transmit that within a reasonable amount of time. Or for instance, for things like signing, I was mentioning this idea of, say, some simple ledger. You don't necessarily, like with signing, you don't need to sign the original big data. You can always use this trick of hashing your data and signing the hash, and hashes are small. Or for instance, that's kind of what's going on with ZK rollups, right? Instead of doing proofs like over large data, or putting big proofs, every single proof on the blockchain. Nowadays, people are doing ZK rollups, which is basically aggregating a bunch of proofs and posting this aggregate on the blockchain, because that takes time. So thinking about like some forms of a rollup for that could be interesting. Yep. Basically, what we foresee is, say, starting with some couple of ground stations, then expanding the coverage, which will enable more availability as the satellite rotates and becomes accessible to those different ground stations. So, yeah, I guess, Yontam, do you think like latency is or like this kind of, should people assume communicating through different ground stations, or kind of assuming one? I guess that's something they can also play with. I guess one thing that's important, like at this point, it's fine to we're working here. You're working with the simulator, so at this point, it's also fine to kind of go wild and sort of ignore or not be entirely kind of blocked on some of those constraints, because we want those ideas, and potentially some of those constraints will be resolved or addressed in the future based on how many use cases there are around them. So we we want your creativity at this point, and then we'll think about what are the ways to address those wild use cases, and whether satellites can reasonably do it, or whether some of them are outside the scope of what the current hardware will support. Yeah, good question so far. Yeah, like that.
Yeah, 100%. Does anyone else have any more questions or comments? Okay, well, that was great. A lot of interest to that. I mean, this topic is really fascinating. It's a really important part of the industry. You can imagine the importance of creating redundancy and being able to ensure that blockchains continue to function. So I think with that, if there's no more questions, I think I would just like to say that, of course, not only has Yan announced bounties, we've got bounties from other workshops. So we have just launched the dev post for the Blockathon DAO. So people can, as they've announced, start bounty straight away. So you don't have to wait till the Blockathon starts on the 18th. You can start the bounty straight away. So if you're interested, you can join our dev post and start working on the bounties. There'll be more information about each of the bounties as well on GitHub. So just looking for the announcements or comments in the general to see more information. Yeah, Daniel, do you have anything to add?
I think just like some questions that I got on DM is when can we start building towards the final submission, and how does it gonna look like? So now we're on Tuesday. It's Tuesday in the part of the world where koalas live, and I guess like Monday night elsewhere. You can start already building, and Jan shared the bounties, so you can already like work towards those bounties. Or if you have an idea that you believe a cryptographic signature in space can be useful for, or from other projects, feel free to start building your projects. Get access to mentors like Jan, like Jonathan, that would be happy to answer questions with regard to bounties, with regard to any integrations there. Like, get started. The ball is in your hand. So yeah, that's it.
I just want to quickly check some I just want to quickly present one slide with instructions that I forgot to kind of skip before that. So just before we wrap it up, the instructions to submit, essentially the best thing if you're submitting code, whether it's a bug fix or a new team or like a new use case you built on top of this crypto theme, essentially take those repositories that I pointed to. I'll share the links again, fork them, and then once you committed your code, create a push it and create a pull request. And that will be the easiest way for us to kind of pull it into the repo. It's worth creating also a separate branch. Please submit into a separate branch, not into master. And then once you've done that, send us a note to Discord so we know we're notified of this pull request and we can check it. Yeah, that's pretty much it. So yeah. And welcome to ask us questions on to message us on the Cryptosat channel, and we'll address any questions. We're in California time, so in PST. So take it into account. We do need to get some sleep, but we'll try to be as responsive as possible throughout this blockathon. So looking forward.
I guess maybe last comment is please do send your tweet and at Cryptosat bot, because legit astronauts aboard the International Space Station are going to get it signed, and if you're lucky, you might even get some shreds of chickpeas, hummus leftovers from their feast, because Jonathan sent them some hummus to grow there. Yeah, so definitely tweet at Cryptosat bot and get your NFTs or other shenanigans signed by the International Space Station crew with the Cryptosat Simulator.
Yep, and I did the Twitter ID at the Cryptosat channel for everyone.
Yeah, and all the links and the bounties and resources for this, besides being shared on YouTube, we can have it shared also on the Discord. So yeah, let's make sure to spam the server with hummus tweets. Cryptosat bot hummus tweets.
Yes. Great. Love hummus. Okay, I think with that, we'll wrap up with this workshop. Thanks everyone again for coming. And make sure to get hacking. Time's ticking. Blockathon's coming soon. Bounties are available right now. You don't have to wait. So get your ideas in, start forming teams, start making koala friends. These are all very important part of the process. And yeah, who knows? Maybe we'll create koala spacesuits and we'll all go together to the moon. Maybe, I don't know, something like that. Okay, I think we're done. Thanks, everyone.
Bye-bye.